Hi guys, so we're on the second lesson in our sequences unit, and we're going to talk about arithmetic sequences this time. Our essential question is, how do I write a recursive and explicit formulas for an arithmetic sequence? So we're going to talk about recursive and explicit formulas. Before we get there, we're going to just do a slight review and talk about graphing a little bit, and then you're going to do a few problems, and then we'll come back and talk about recursive and explicit equations. So just to review some general vocabulary, a sequence is an ordered list of numbers. Okay, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. I have an example here for you. What am I doing every time? I'm adding 5, right? So I'm adding the same number. Okay, so the first thing we want to do is tell whether the sequence is arithmetic. So how do I tell if it's arithmetic? Well, if I'm adding or subtracting the same number every time, then it's arithmetic. If I'm not adding or subtracting, or I'm not adding and subtracting the same number, then it's not arithmetic. Okay, and then the directions go on to say if it is. So the first thing I'm going to do is tell whether the sequence is arithmetic, and then the second thing I'm going to do is, if it is arithmetic, I'm going to find the next two terms. Okay, so let's go ahead and look at this. So how am I going to do that? I'm going to look at the difference between here. So I'm going to say -1 minus a -7. Well, what does that equal? I'm pretty sure that's a +6. And then I'm going to look here. So I'm going to say +6 here. And I'm going to say, what's the difference between 5 minus a -1? Well, again, that's a +6. Great. I'm going to just check one more time. What's the difference between 5 and 11? Or how do I get from 5 to 11? I add 6. So I'm pretty sure that my common difference here is +6, so that means it is arithmetic. Oops, am I going to spell it wrong? A-R-I. I did spell it wrong. Here, let's fix that here. A-R-I, arithmetic. Okay, there we go. Arithmetic. And then I need to find the next two terms because it is arithmetic. So 17 plus 6 is 23. And 23 plus 6 is 29, ... Okay, so we're done with that one. Now we're going to move on to the second one. So how do I get between 1 and 4? Well, I add 3. And do I add 3 to 4 to get 16? No. So I'm not adding the same number. I'm not subtracting, obviously, the same number either. What am I doing? Well, I'm multiplying by 4. So this is not arithmetic. And that's all I have to say. I don't have to say what it is or anything. I just have to say whether it's arithmetic or not. And then if it is arithmetic, find my next 2 or 3 or how many ever terms the directions tell you to find. In this case, it was 2. All right, not too terribly hard so far. Okay, so we're going to go ahead and go up and define another word here, or set of words. It's called graphing an arithmetic sequence. Before I go ahead and define this, I do want to remind you that if at any time you're doing the work and you can't remember what something is, at the bottom of every unit or every module, there is a glossary for the unit, and all these words are in there by the unit number. So all the ones from lesson 1.1 are in the glossary under lesson 1.1, and all the ones for 1.2 are under 1.2, and they're alphabetized for you. Okay, so here we go. To graph an arithmetic sequence, create a table where the terms position in the sequence is the x value. Okay, great. Okay, so that means if I have this is my sequence right here. I'm given this sequence 0, 5, 10, 15, and 25. That's not my x, that's not my position, my term's position. These are actually my terms, so that means this is going to be the y value in my table. So I'm just going to go ahead and fill in my y value here. So I've got 0, 5, 10, 15, 20, 25, ... Okay, So the term's position is its x value. So this was my 0 was my first term, so that's going to be number 1. And 5 was my second term, and 10 was my third term, and 15 is my fourth term, and 20 is my fifth term, and 25 is my sixth term, and so on and so forth. Okay, and that's it. That's how I make a table to graph. Then I have an x coordinate and a y coordinate, and I can put it on a graph. It's as simple as that. Okay, now we're going to actually try it and see what a graph of an arithmetic sequence looks like. Okay, so let's slide this up a little bit. It just says graph the sequence, so I'm going to make this a little bigger so it's a little easier to see here. There we go. So I'm going to make a table. It says make a table, so in order to graph it, I'm going to make a table. So I've got my x and my y values. Okay, so my first term in my sequence is -2. And the second term in my sequence is 1. And the third term in my sequence is 4. And the fourth term in my sequence is 7. And then I can say ... if I need to. Okay? So now I'm just going to graph those points on my graph. Since I have a graph there, I'm just going to plot them. So the first one would be, my first point, if I'm going to write this out, is going to be 1, -2. So I need a point at 1. Here's my x value, 1, and my y value is -2. So I've got 1, -2. So 1, -2 should be there. And my second point is going to be at 2, 1. So I'm going to graph 2, 1, over 2, up 1, put a point. My third point should be at 3, 4. So 1, 2, 3, 1, 2, 3, 4. Beautiful. And the last one is at 4, 7. So I'm over at 4 and up 4, 5, 6, 7. Beautiful. So now the question becomes, I just need to kind of talk about this for a second. Do I connect them with a point or not? With a point. Woo! Do I connect them with a line or not? Well, my answer to that is this is a sequence. Did it give me, in my sequence, is there a 1.5 term? Right, so my x terms are first term, second term. Well, do I have a 1.5 term? I don't in this case. I only have a first term, a second term, a third term, and a fourth term. This is what they gave me in my sequence. So I'm not going to connect my points with a line at this particular moment in time because all they gave me is -2, 1, 4, and 7. So this is what we call a discrete graph. Okay? Because discrete just means points on a graph. There's nothing else. That's it. It's those 4 points and that's it. Okay? So now we're going to do the last graph here. And we're going to do it exactly the same way. So I'm going to make a table. I have my x values and my y values. And my first term is -9. My second term is 1. My third term is 11. My fourth term is 21. And my fifth term is 31. So now I'm going to have 5 points on this one. Great. So my first point is going to be 1, -9. So 1, -9. It's just above -10, so somewhere in there. And my second point is going to be 2, 1. So over 2, up just above the line here. There we go. And then my next one is 3, 11. So just above 10. And if you notice, my scale is counting by 5s, so that's why I'm just going just above the line. 4 and 21. So 4 and 5, 10, 15, 21. Okay. And then 5 and 31. So 5, 10, 15, 20, 25, 31. And you can see it's roughly a line again. So arithmetic sequences, when I graph them, should form a line. If it doesn't form a line, it's probably not, one of two cases, it's probably not an arithmetic sequence, or you plotted a point wrong. Just, that's a possibility too. So that's it about the graphs right now. We are going to go do some practice problems, and then we'll see you back for the second half of this video in just a few moments. See you soon. Bye.